Okay, all are recorded and on YouTube. You want to review? These are the syllabus. You need to know how to derive potential energy formula and then kinetic energy formula and recall and define work, define power and show that P equals to F times V. Then you need to know how to draw the graph where you drop the object and you measure from where you drop it. So potential energy is maximum. No air resistance, kinetic energy will be a straight line because it's basically potential decrease, kinetic increase. But if there's air resistance, then it will initially be a straight line and go away from the straight line, no? Because there's work done against air resistance. Right? And all these formula must be in your head. All this formula. This one is A2. Okay. What is the answer for this one?
Efficiency is output or input. D.
Donkey, okay. Good. This one? Either you memorize it or you calculate it out.
Um,
Calculate the average speed. Estimate the mass of a human being, about 60 kilogram. Then calculate. Right? Average speed. Right? Mass of a person is either 60 or 70.
what about C? I think his answer is C.
Yep, answer is C. What about this one? The formula is lost in kinetic, again in potential energy. Right? M can cancel off. You get this formula. So second part, right? Replace this one with half mv squared. M doesn't come in. M cancel off already. And then the height is x, right? 2gh is x. So cancel off, you get this one. Right? This is a quarter. Take a 4 across there is 8. Then v square and v square are the same. So this 2gh goes to 8gx. There's a quarter h. A can.
Yeah.
This one is normal in the syllabus.
Hey, teacher, can I see that one again?
Which one? This one.
Yes.
Yeah, the formula for
Alright.
basically is v squared. V squared divided by h is a constant. That's how you can use that if you want to. Okay, anything, any problem?
No.
Okay, then let's go to, how about this one?
A.
Okay, good. Number 7.
2,500. Oh, wait, still.
10 or not?
Yep.
Try this one.
Is it C?
The key is constant speed. Constant speed straight away means there's no change in speed. So there's no change in kinetic energy. Kinetic energy is 0.
Oh,
Yeah. Potential energy is never 0. Donkey. Okay,
yeah.
is applying your definition of work done.
Wait, teacher,
Yep. What's the answer?
the diagram is quite confusing.
Basically, you just start from here at rest, and then you move up to there at rest again. So what is the work done? He asks you.
WR,
So what is your answer?
D, donkey,
C.
donkey.
No. Work is force times distance moving direction of the force. The force and the distance must be the same direction. So that's the weight,
Uh,
the force, that's the force. So that's your distance x. Right? Gain in potential energy equals to mgx equals to work done times q. The answer is 0.
oh,
Okay. Force and distance must be in the same direction.
all right.
This one? Right? The plank is smooth. Smooth means there's no air, there's no friction. What's the minimum work done?
C.
Right? Minimum work done is gain in potential energy, mgh. C. Okay?
Yep.
Yep. Can? Yeah, called constant
Constant
speed
speed.
means there is no change in kinetic energy. So basically, it's just the work done is done by this force, right? And it causes a gain in potential energy and work done against friction, right? Okay, there's a rough surface there, so there's frictional force there. So this is not given. Uh, that one is given, which is that times this distance 40 meter, and then there's a change it to Newton. That height is 12, and that's what you want to find. Work done against friction. A.
Delta E is what? Change in energy.
Gain in potential energy. Gain in potential energy. Anything not clear?
Wait. All right. Yeah, I got it.
Okay.
It's just so energy dissipated by heat, meaning friction.
Work done against friction, no? Is
Work done
dissipated as
against
heat, no?
friction.
It appears as heat, no?
Oh, okay, I see.
How about this one? E is constant speed. The answer can be kinetic energy is constant A or B only. And then potential energy is mgh. So it's a straight line, no? Okay. B.
Yeah.
This one given you already. No point working already. Yep. A picture of the diagram in your head. There's a weight, there's a frictional force. Right? Steady speed again. Constant speed. So E is in equilibrium. Force upwards equals to force downwards. Kv friction equals to mg. Nv is take the k down, cross multiply. Kinetic energy formula. Replace the v with that v there. Okay. Donkey.
For equilibrium. KV equals mg.
Equilibrium this one. Terminal velocity. Force downwards equals to
That means
force
it's
upwards.
floating. No?
Say again.
Does that mean that the raindrop is floating?
Raindrop is moving with terminal velocity. So the only two forces acting. The mg is the weight, and then the retarding force or air resistance or friction.
Oh, okay.
It's called retarding force. Okay,
Yeah.
this one. Right now, what is given now? Potential energy at P minus potential energy at Q, yeah, is 50 kilojoule. Right? Total mechanical energy, kinetic plus potential. Conservation energy, right? Total mechanical energy at P to total mechanical energy at Q. And then there's work done to must add it in. Work done against friction. Okay, we are told this is moving, right? 5 kilojoule, 5 plus, right? There's a kinetic energy, there's a potential energy at P. Then at Q, there's work done against friction. And then take this one across there, right? Which is this one. Then this one, this one, the one what you want to find. Okay, can or not? Anything not
Yeah.
clear? Can.
Yeah.
See whether you can get 0.3 watt or not.
Wait, so what's the formula for power again? ET, is
Power
it?
by right, this one is the rate of change in the rate
Energy?
of doing work, lor, or change in work against change in time, lor. Change in work
Oh,
over change in time, lor. Work done per unit time. So you look at the gradient, lor. Power is gradient, lor. Greatest gradient is this one, lor. Okay, now
you can see. 0.4.
This part, this straight line is the greatest gradient.
Oh, all right.
Right? Try 105. A sphere has a volume V and is made of a metal of density rho. Write down the expression for mass m of a sphere in terms of V and rho. Right? We will try to combine two parts of syllabus together lah, so that they can cover the whole syllabus lah. Memory work only this one.
Rho VG. Wait.
Density is mass over volume. Rho times V.
Oh,
The sphere is immersed in a liquid. Explain the apparent loss in weight of the sphere. Right? This is testing you on pressure. Pressure increases with that. That's the first step. Pressure at the bottom of the sphere is greater than the pressure at the top. Thus, the resultant upward pressure on the sphere, they appear as upthrust on the sphere. Right? Force equals to excess pressure times cross-sectional area of the sphere. This upthrust causes the apparent loss in weight. Can.
all right.
After that, calculate. After you have done all that, now calculate. A sphere has a mass that, when the sphere is released, it eventually falls with a constant speed 6 cm per second. For the sphere traveling at constant speed, calculate the kinetic energy. Right? This is a giveaway point. Calculate kinetic energy only.
Yeah.
Half mv square, write the formula down.
Oh,
Just put 1 mark. And put in a value. Right? Remember to change that to meter per second and calculate out rate or loss of gravitational potential energy.
oh. MGH.
mgh divided by time. Rate. So you can
Yeah.
think of height fallen in 1 second is 6 cm. Change it to meter. So rate of loss in potential energy is mgh divided by t. Okay, that's all. You get the answer. Can?
Uh, okay, yeah, I got it.
Remember our exam, you need to bring your protractor and compass.
Yeah, but it doesn't state the time.
Huh? Time you can
The
treat
rate.
as 1 second. Or h over
Oh,
t is your speed.
true.
H over t is your speed, average speed. Suggests why it is possible for the sphere to have a constant kinetic energy while losing potential energy at a steady rate. Right? Have in your mind what are the forces acting? Mg, frictional force, upthrust. So loss in potential energy is used to do work to overcome the drag force. That one, friction between the object and the liquid. At terminal velocity, the weight is balanced by the upthrust and friction. The work done appears as internal energy, as thermal energy of the liquid and the sphere. It means the liquid and the sphere become warm. That's all.
Oh,
Okay,
yeah.
right? That's what it is all about. there's a motion, so the drag is always opposing to the motion, no? And then there's the in liquid, upthrust is significant, no? Whereas in air, upthrust is negligible. No? Right, this one? Right, this is figure 14, 4.1.
Okay.
This one is straightforward lah. Give you the mark,
Yeah.
GH, that's all. Right, write down the formula. Put in the value in case you write this one wrongly. At least you get a mark for formula.
8.79.
Okay,
Yep.
calculate the total kinetic energy of the stone as it reaches the sea.
Half. Okay. 0 point. I forgot the mass already.
Mass is 56 gram.
Yep. B 9.07.
Okay, the initial kinetic energy and potential energy converted to kinetic energy at this point, at the sea level. That's what we are calculating. Right? Initial kinetic energy changes to kilogram. That's the speed or velocity. Then we have calculated this one already. So we get 18. Use your answer in A part 2 to show that the speed of the stone as it hits the wall, as it hits, is approximately 25. Right? Use this one, no? Yeah, half mv squared. Right? We get 17.9 half m mass and v squared. So this is the speed. This is the final speed, final velocity, sorry. So it has a direction. Even though it's the final speed, it has a direction. Direction somewhere there, right? Because it has a horizontal speed, there's a vertical speed. So final direction somewhere there. State the horizontal velocity of the stone as it hits the water. Yep. Does the horizontal speed changes?
Uh, I don't think so. Same.
Must be sure. Horizontal speed doesn't change. Okay, we got 10 more minutes.
But as it hits the water, meaning like it hasn't hit the water, right? But if it hits the water, the horizontal speed changes.
You just touch the water if you like lah. Just about to go inside lah.
Or just about to. Okay.
Uh, so they give you a graph lah. Scale drawing. So use your vector diagram to determine the angle with which the horizontal at which the stone hits the water. Okay, you want to find this angle. So you got 18. Right? Take 1 square, represent 1 meter per second. No? So 18 square. No? And then there is your, right? You can drop a vertical line there from the 18. At the end of this arrow, draw a vertical line. And there's your 25. Right? So use your compass to put a curve there. Then you can measure the angle. Okay.
Yeah.
Okay. We have more or less completed already, but
Yeah.
since you got a bit of time, I
Teacher,
give
does
about
that question usually come out in exam? The
say again.
compost. Does that question come out in exam?
Yeah, this is a partial question. This
The
one is
compost one. No, the compost
207
one.
June. 207 June.
The compost one.
Yeah, come out. You have to use a compass. You know how to measure 25 meter per second.
This one came out?
Yeah.
Wow. Wait,
Okay.
so you are supposed to do the compost one?
That's why I say you must bring a compass and protractor.
Shit.
This is the first time it came out, but haven't come out. I don't know whether it will come out or not. So a lot of people will be caught. Oh,
Yo.
protractor is important. You must have a protractor.
Okay.
Define the concept of work. Yeah.
What? Uh, force, force times distance.
Not force and distance. Distance move in the direction of the force. Product of force and distance move in the direction of force. Important to get it right. This is a free mark for you all. Okay, that's the graph. Read the question before I turn it to the next page. A tennis ball falls vertically through air. Figure 8.1 shows a variation with kinetic energy of the ball with distance if fallen. The ball reaches the ground after falling a distance h naught. So this is your ground, h naught. Describe the motion of the ball. Yep.
Describe the motion. What does that mean?
As the ball falls from rest, it experiences a decreasing acceleration. It reaches constant speed when the acceleration is zero because there's air resistance.
Oh, yeah.
On figure 8.1, which is the diagram there, draw a line to show the variation with height of the gravitational potential energy of the ball. At h equals h naught, the potential energy is zero. Yep. If there is no air resistance, kinetic energy will be a straight line, and potential energy will be a straight line. Right? So kinetic energy will go straight, that part there, the straight part, go to the top there.
Yeah.
And potential energy will be coming down. Right? We draw a horizontal line, and then that will be potential energy.
Oh.
Can
Yep.
we may not be able to finish this one, but since we got 4 minutes, then give you a short break, 15 minutes break. Let's try this one.
Okay.
Okay, so that is where it starts. Then it lifts up by 13 cm, let go. Then after the collision, A will move with velocity V and B will move with velocity. Right? It comes down, then it will have a velocity V, then it hits that B, B will have a velocity of 0.9. So understanding the physics involved. In in B, sphere A has potential energy, and when it moves down, right? Sphere A has potential energy. As it moves down, of it, it is converted into kinetic energy. As it moves down, it converted to kinetic energy.
Yeah.
Momentum is observed. After collision, the speed of A and B are given. After collision, speed of A and B are given. Conservation of energy. So use the principle of conservation of energy to show that the speed of sphere A immediately before collision is 1.6. Right? Let the mass be m. Loss in potential equals to gain in kinetic. To cancel the m, subject u is square root of 2gh. Put in your value. Right? Change it to meter. This is the speed before collision. Okay,
Yeah.
determine the speed of of v of sphere A immediately after collision. Momentum before is called momentum after. So mu is mv, right? M is also m and 0.9. So we have calculated already. M and M will cancel off. So take our 0.9 across there. This one we have calculated just now. Then state and explain whether the collision is elastic or inelastic. Relative velocity of approach. Right? Initially, this is stationary. This one comes down with a speed of that. Sorry, speed of 1.6. Right? There's approach. Relative velocity of separation 0.9 and then 0.7. Subtract that this one. Since both velocity are different, the collision is inelastic.
Yo, where's the separation?
Separation before collision is called separation.
Oh,
Relative velocity of separation. Sorry,
okay.
relative velocity of approach is before collision. After collision,
Okay.
both of them at different speed. This one is
Oh,
greater.
yeah.
So they are
Yeah.
separating.
Okay.
Okay, I think we don't have much
Yeah.
time. So we will give you
So
15 minutes.
kinetic energy is not conserved, right?
Kinetic energy is not conserved, only momentum.